Welcome to Sundar's lecture. This is lecture number 87, and in this lecture we are going to see hybrid parameter, or we can simply call it as H parameter, and then we are going to see what is ABCD parameters, right? So what are all the topics we have seen in the previous class? See, we have already derived what is Z parameter and Y parameter in the lecture number 84 or 5, I think, and then in the previous lecture, and what we have done, we have gone for relation between Z and Y parameter, right? So we have taken a example circuit and we try to get what is the Z parameter for this circuit. It becomes infinity. But for this circuit, if you are going for Y parameter, then you are getting the answers, right? This is the Y parameter of this particular circuit. So Z parameter is not existing, which means it is infinity for this circuit, but Y parameter exists. And also we have taken, this is the thing we have got for the Y parameter, and then we have taken another circuit, another example with impedance connected like this, and if you are trying to solve for Y parameter, it becomes infinity, but for Z parameter we are getting the values, right? So we have concluded that in all cases you cannot say that Z parameter is the inverse of Y parameter or Y parameter is the inverse of Z parameter. It depends on the circuit components, right? So that is what we have seen. And in this lecture, we will see what is hybrid parameter. See, the same thing. This will be two-port network. This is the input port and this is the output port. In current I1, current I2, V1, V2, everything is same. And this current direction is very important. This is the this current direction. I have again made a mistake. This current direction, it won't be like this. This will be in opposite direction. This is the current direction, right? So this is the two-port network. And if I am going to write an equation like this, for example, V1 in terms of I1 plus V2, hybrid, right? In the previous lectures, maybe if you are going for Z parameter, see how we have written the Z parameter: V1 in terms of I1 and I2, V2 in terms of I1 and I2, right? We have just gone for V1 and we have just gone for V2, and in Z parameter we would have gone for I1 and I2 in terms of V1, V2, V1, V2, right? So you try to understand, but here we are going for combination. That is why we are calling it as hybrid parameters. What will be the combination? V1 in terms of I1 and V2. That means then the other term, it is I2 in I2 in terms of I1 and V2, and I'm just taking this one to be H11 and this one to be H12 and this one to be H21 and this one to be H22. That's all. Now what will be the equation? How will you write this one in matrix format? It is very simple. This is V1 and this is I2. V1 and I2 in terms of H11, this is H12, this is H21, this is H22, right? This is H22, and the multiplication will be I1 and V2, right? V2. So now this is the H parameter. H parameter, or we can call it as H matrix, anything it may be, right? So now how will you find the H parameters, right? So for example, make this as equation number 1 and this as equation number 2. So now from 1, if you made V2 to be 0, how will you make the V2 to be 0? And if you short circuit the second port, so let me draw the diagram. So this is the diagram, and you see here we have short circuited the second port, which means output port, and what we are getting here, V2 to be 0. Then what you will get if this equation becomes 0, V2 is becomes 0, then how I can write this one? So I1 should be H11 should be is equal to V1 by I1, and with respect to V2 to be 0. And what is this one? V1 by I1, you will obviously get this equation. What is the unit? V by I, it will be ohms. It will be ohms, right? Ohms. And from the second equation, this is from 1. This is from 1. And if you are going for from the equation number 2, what you will get? You will get H21. So what will be H21? So H21 will be I2 divided by I1 with respect to V2 is equal to 0. And you see this parameter H21, if both are amperes, then what happens? It has no dimension. No dimension. It don't have any dimension. And what we can do for the other thing, you need to put I1 to be 0. And what happens if you open circuit this one and you apply the voltage here? Apply voltage here, measure V1 and I2. I am not going to draw the diagram anyhow. Anyhow, I will draw it down. So now you see this is the two-port network. I have just open circuited the first port and I have applied the voltage in the second port. Now I1 will become 0, and if this I1 becomes 0, what happens to H12? You will get H12 should be is equal to V1 by V2 with respect to what? I1 to be 0. And you see here this particular H parameter value will have no dimension. Try to understand. Why? Because both are voltages. If you divide both voltages, then you don't have any dimension, which means what I am saying, you don't have any SI units, right? Then this is from 1. This is from 1. And if you are going for the expression number 2, what you will get? Obviously, you will get this term to be 0. So H22 will be is equal to I2 by V2 with respect to I1 is equal to 0. And what is the dimension for this one now? Obviously, this dimension will be opposite to ohms, and you can call it as conductance. Right? So now you see how we are getting all the 4 parameters, right? 4 parameters have a different things, right? H11 is ohms, H21 is which has no dimension, and H12 has no dimension again, and H22 has conductance. So you see these kind of things, H parameters, will be very helpful if you are going for electronics and devices, right? So electronic devices will have these kind of H parameter values, and there you can see the application of these hybrid parameters, right? Now the next, maybe from here I will write down the expression anyhow. What will be the expression? This is I1 and this is I2. Sorry, not I2. It may be 1 minute. And you see this is the H parameter, right? So now what we can do, you just keep this one here, I1 and V2, keep this, and you just bring this H parameter, that means H11, H12 and then H22 inverse, and it will be V1 and I2. And commonly we can call this matrix to be G parameter now. G parameter. See, there are so many things, but you try to understand these kind of things very clearly. So this will be I1 and V2. If you are getting it in the back side, backward, then it will be G11, G12, G21, and it will be G22. Then this value will be V1 by I2. V1 and I2. So this is the things we can see in the H parameter, right? Now we will go for ABCD parameter. That will help you in transmission line. See, whatever the parameters we are seeing in this particular two-port network, it will be applicable in somewhere in the higher version of the papers. Maybe if you are a electrical department student, then obviously you will use all these kind of parameters, right? So we will see ABCD now. So the next one will be ABCD parameter, or we can call it as T parameter, or it may be transmission line parameter, right? So how this will be, see, I will draw the diagram. This will be an inductor, and you will have a capacitor like this, and this will be another capacitor. See, this will be L, and this will be C1, and this will be C2, plus minus, this is V1. See, the current direction is like this, I1, and you see plus minus, this is V2. See, try to understand one thing, this current direction should be like this. This is in opposite direction. Try to understand. You have to take this as in this direction, right? Opposite direction as compared to other three parameters. Try to understand it clearly. See, wherever you see, we have taken the current in the opposite direction, but here you have to take the current direction like this only, in opposite direction. Try to understand that one very clearly. Right now, what is this ABCD parameter? What is these kind of things will be there in transmission lines, and you have to get the parameters to simplify the problems or to understand the transmission line in-depth concepts, right? So now what we will do, we always take the input as this one, or which means we commonly call this as sending end. This is actually sending end. This will be receiving end, right? Receiving end. And you can see these kind of things in transmission and distributions, and so that you can easily understand. Maybe if you are a first year electrical student, you may not understand these kind of things very clearly. But if you understand the idea of ABCD parameter, then you can apply that in the transmission line parameters, right? So now what we will do, we try to write V1 in terms of, maybe I will take a different color, V1 in terms of V2 and I2. V1 in terms of V2 and I2, and I1 in terms of V2 and I2. That's all. So this will be A, this will be B, this will be C, and this will be D. That's all. This is equation number 1. This is equation number 2. So what will be the matrix now? So matrix will be like this. This is V1, this is I1, and that should be is equal to A, B, and this will be C, and this will be D, and that should be is equal to V2 and I2 in relation between the sending end and receiving end. See, I have written the sending end component with respect to the receiving end component. That is what we are calling it as ABCD parameter. And how will you get the CA value now? So when will you get the CA and C? If I2 becomes 0, and if you apply V1 here and make this as 0, make this the secondary port to be 0. So I am not drawing the diagram, you just try to imagine yourself, because we have done many times. Anyhow, maybe to understand things I have to draw it down. So now you see this is the diagram, and we have applied voltage in the first port, which mean you can call it as sending in port, and in receiving end we have just left it as open. So I2 becomes 0. So if I2 becomes 0, so from equation number 1, what you will get, this term becomes 0. So the A parameter will be nothing but it is V1 by V2, right? V1 by V2. With respect to I2 becomes 0, right? And then from equation number 2, what you will get, this term becomes 0, and C will be is equal to I1 by V2. with respect to I2 is equal to 0. And we have seen these kind of things already. What is this one? This one will be dimensionless, no dimension. This don't have any dimension. And what will be this one? This one, I by V, obviously it is nothing but conductance. Conductance. Right? This is the conductance one. And how will you find the value of D and B? Make V2 become 0. I will draw the diagram. And you see now what we have done. We have just short circuited the second port, which means sending in receiving in port, and V2 now becomes 0. So these two terms will be 0 now. And what will be the B? B should be is equal to V1 divided by I2. With respect to V2 becomes 0. Right? And what is this dimension? It is very simple, right? This dimension will be ohms, right? Ohms. V by I will be ohms, right? And what happens to the value of D? Maybe V2 becomes 0. So D will be is equal to this is I1 by I2 by I2. And what is this one? With respect to V2 is equal to 0. And if you are going for dimensions, it has no dimension. It has no dimension, right? Now, this is the ABCD parameters, and you know how to find now value of A, value of B, and value of C and D with respect to short circuiting the open circuiting the sending in port, which means no load is connected in other way, and if there is a short circuit, then what will be the value of B and D? That is what that is how we are just finding out ABCD parameters. So we try to consolidate all the parameters now. We have seen 4 different parameters, and each one I will just write it down. Z parameter, and I will write it down the equation so that you can easily compare everything. So what is Z parameter? It is with respect to V, we have to write Z11 I1 plus Z22 Z12 I2, right? This is I2. And then you have to write V2 is equal to Z21 I1 plus Z22 I2. This is Z parameter. And what is the then Y parameter? We have gone for Y parameter. What is Y parameter? Y parameter, you have to write the expressions in terms of I. So it will be Y11 V1 plus Y12 V2, and this will be I2, which is equal to Y21 V1 plus Y22 V2. Right, this is Y parameter. And if you are going for hybrid parameter, H parameter, what you will get, you have to combine everything, right? So it will be V1 should be is equal to H11 I1 plus H12 V2. And if you are going for I2 parameter, I2, it will be H21 I1 plus H22 V2. This is H parameter. And if you are going for ABCD parameter, what you will get, it will be V1 should be is equal to A V2 plus B I2, and I1 should be is equal to C V2 plus D I2. So these are all the parameters, right? Is Z parameter, Y parameter, H parameter, ABCD parameter. Now, what is the thing we are going to see in the next lecture? We are going to get the conditions for reciprocal. If the circuit is reciprocal, or what is the condition for Z, Y, H and ABCD parameter to become reciprocal in a circuit? That we will see in the next class. To go through all these parameters, and we will see in the next class. Thank you.